Good morning. Today we are going to discuss on key management. Key management is related to generation, storage, distribution and backup of keys. The focus in this chapter is on management of public key, private key pairs. Basically, this system is for the algorithms where public and private keys are used. Consider a situation where party A and party B are communicating with each other using a public key algorithm. So that means whenever A wants to send any message to a B, A will going to use B's public key to encrypt the message and send the message in a secured fashion to a B. The above possibility makes a couple of assumptions. The first, B must have securely communicated his public key to A at some point in past. By securely means that A actually receives B's public key and not a public key from someone posing as a B. The second implicit assumption is that if B's public key private key pair is changed, then the new public key will be swiftly and securely communicated to A. However, this may not be always practical. For example, if B is an e-commerce website and A is some customer to a B, then it is difficult for A to communicate A to get the key of B, which one is changed recently. The second possibility that every entity's public key is securely maintained in the centralized directory. Suppose A wishes securely communicate with an e-commerce website, say B-Mart. All A has to do to obtain the B's public key is to query directory. To get this public key of say B, A has to query that directory for it. The question here is, who would take the responsibility of maintaining such directory? There is a huge scalability problem that is associated with the directory-based approach. Apart from that, directory-based approach also need an infrastructure to support this directory, could also become a bottleneck besides being an attractive target for spoofing and denial of service attacks. So to overcome these particular problem, the approach one which is used to distribute the public key is, say, a trusted third party will maintain the certificate through which it will going to distribute the public keys of, say, any party to other parties. The idea of distribution of a public key using a signed document, we call it as digital certificate approach. A digital certificate is a signed document used to bind a public key to the identity of the person. The entity that issues this certificate is trusted entity called a certification authority, CA. Okay, please just keep this term in your mind, because again we're going to use these terms in the fifth module. The certificate types. There can be a various types of certificates with different levels of security. So we're going to discuss one such certificate format, that is X.509 digital certificate format. An ITU standard specifying the format for public key certificate. X.500 is the format that is specified by ITU for public keys. These certificates will going to have a following fields. The first one is certificate serial number and its version. The second field in that certificate is issuer's information. The third field in that certificate is subject information. The fourth field is subject's public key information. Then the next field is validity period. So for how much period this certificate is valid, that information will go to be the part of this validity period. Last one is a certificate signature and associated signing algorithms information. One such certificate is shown over here. As I said, these are the certain fields that are associated with certificate. So first, version, certificate number, because X.500 has different versions, version 1, version 2 and version 3. So version 1, certificate serial number, algorithm and parameters which are say used like signature algorithms, basically which will be useful for a person to encrypt or decrypt the message based on public key, and who is issuing this, his name will going to be there, and validity period, like for how much period this certificate will going to be valid, and name of the party whose public key it is, the subject's public key information, those details, algorithm, parameter and key, the issuer's unique identifier who is issuing this certificate, his identification will going to be there, subject's identification and extensions, is there any additional information required to be there, will going to be put into this extension fields, and last one is signature. So these are certain fields of this X.500 certificate. Whenever some person gets a digital certificate of some party, he has to perform certain tasks. If a person obtains other person's certificate for him, he needs to check the identity first. This identity check tells it belongs to a person providing to it. It verifies whether this certificate is of a proper person or not. The second one is he checks if the certificate is still valid, since the validity period contained in this certificate is easily done. Then next is signature of CA or RA are present, well, like the who is issued this certificate, his signatures will going to be verified. The party who is receives the certificate also should verify the signatures of CAs and RAs. For that, the party requires CA's public key for signature verification. The CA may be globally known or may be not known to the community that A and B belongs. In this case, a party has to access CA's public key. Next, we are going to discuss regarding public key infrastructure. First, we will talk regarding the functions of public key infrastructure. Public key infrastructure includes number of functions such as certificate creation, issuance, storage and archival. So basically public key infrastructure, certification authority is part of public key infrastructure. So the second function of this PKI is key generation and key escrow if necessary. The third job of a PKI is certificate and key updation if necessary. Whenever a party changes his private key and a public key pair, it's a job of CA to update those changes, and those updated changes has to be presented to the party who is requesting it. And last job of public key infrastructure is certificate revocation. So this revocation of certificate will happen at different situations. First, if the validity period is over, that time certificate will going to be revoked. In case if key is compromised, in that situation also a certificate will going to be revoked. An important function of PKI apart from all these things is to provide safe archival facility for issued certificates. There are crucial differences in support required for private keys used for decryption compared to those used for signing. In the case of encryption and decryption, it is often necessary to have a backup of decryption keys. If not, an employee who loses his decryption key will be unable to decrypt the archival of sensitive data he may be accumulated. For this reason, the PKI within an organization, for example, might hold the private keys in escrow. That is, they may be securely backed up or made available to the owner or the trusted authority, such as law enforcement agencies under the special circumstances. On the other hand, there is no need to back up a private key used for digital signing. If such a key is lost, the owner could inform certification authority or public key infrastructure administrator within an organization. He or she could then obtain the new signing key and receiving a new certificate carrying the corresponding public key. In case the public key is compromised, so the PKI and CA authorities will going to be, say, providing him a new public key, which will be a new private key, which will be in turn forces to change the old public key. An important function of PKI is to provide safe archival facility for all issued certificates. For this reason, PKI within an organization So we'll see now the PKI architectures. The PKI architecture is shown over here in these figures. There are 4 different PKI architecture. The first architecture, we have a single CA, and under which there will be some different users. He is giving a services to these users. Then the second PKI architecture, in which we have a hierarchies of, say, certification authorities. CA1 will going to appoint few certification authorities. In turn, these CAs will going to appoint a new CAs who will going to work under them, who are the trusted parties for them, who will going to issue the certificate on behalf of this CA1 to a end users. So the next, this one is a mesh based approach. In the mesh based approach, so there will be a root type organization, where in this mesh type approach, each CAs in turn have a communication within themselves. They can interact with each other, but whereas in hierarchical, there is all the time one way. So CA1 is the highest authority over here, and he appoints the remaining one. But whereas in this case, these CAs will support each other, and these CAs directly in touch with though their say end users. Apart from that, these CAs also have an authority to appoint new CAs. Last one is the bridge based approach. In the bridge based approach, we are trying to club the things of this approach and this approach. So hierarchical and say single CA approaches are going to be added over here. So bridged approach, there will be a bridged CA who is supporting many of such say architectures. Basically this type of architecture is helping to the organizations which have their own PKIs. Remaining details of this public key infrastructure, we're going to discuss it in the next class. Thank you.